Hello everyone, in this video we're going to see the solution for the Codeforces problem board moves, which is problem C of Codeforces round 642 division 3. So we're given a board of size n cross n and n is odd and each cell of the board contains one figure. So in one move we can select exactly one figure in any of the cell and we can move it to any of the cells with which it is sharing a side or a corner. So from I and j to any of these 8 cells. So what we need to do is we need to move all of the cells into one single cell, and in one move we can only move one figure. So we need to find the minimum number of moves so we can move all the figures into one cell. And for the test case, you can see that for test case 1 it is 0, which is obvious because all the there's only one cell and the figure is in its cell. So for 5, the number of moves required, the minimum number of moves required is given 40. So if you're able to calculate for 5, you'll see the formula and you'll be able to calculate. So we'll see for the test case 5 only. So this is, you can see as a 5 cross 5 matrix, and each of these cells have a figure in them, you can assume. So the most optimum position will be in the center. So the center is having the most optimum position because each of the cell, and you can see that with the example even, that the most optimum position to put all the cells into will be the center position. So we'll be moving all of the cells into center position which are marked with a star. Now what we'll be doing is we'll be moving layer by layer. So I'll just mark the first layer. So first layer is just the outer of it. So I have 1, 2, 3, 4, 5, 6, 7, 8. So the outer layer is having this 3 rows of 3 cells in its row, and the total number of cell in that layer is 8. How is it 8? 3 plus 3 plus 3 minus 2 plus 3 minus 2. So 6 plus 2, 8. Now, if you notice that each of these cells will take only one move to be positioned into the center. Why? Because all of these cells are either connected to its by its side or by its corner. So I can move one into the center with one move. I can move cell number 2 into the center with one move. So all of these 8 cells can be moved into the center with using only one move. Now we move to the next layer. So next layer will be this. So 1, 2, 3, 4, 5, 6. So we have 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So as you can see, this layer has 5 cell in the first row, and it has 16 number of cells. Now how is it 16? 5, which is the number of row, so 5 plus 5 plus 5 minus 2 plus 5 minus 2, so 16. Now if you notice, each of the cells, each of these 16 cells which are marked 1 to 16 in a clockwise fashion in the next layer will take 2 moves. Each of the cells will be taking 2 moves. Why? You can see for this cell, for example, I can move here to here in 1 and here to here in 2 moves. This I can move here in 1 move and here in 2 moves. So each of the cells 1 to 16 will be taking 2 moves. Now if I go to the outer layer, suppose it was 7. So the next outer layer will have 7 cells in row, and it will have 7 plus 7 plus 7 minus 2 plus 7 minus 2 total cells. And each of those cells would take 3 moves to be positioned into the center. So if you have to see what we're doing code wise, so we have a counter which gives me the number of cells in the row. So let's take for example 5 only. So I have 5, n is equal to 5. So the counter will start from 3. So counter is 3. Now the number of cells in that layer will be 3 plus 3 plus 3 minus 2 plus 3 minus 2, and we'll have a variable count. Count will be initially 1. Now these will be 8 cells, and each of these cells will take one time. So 8 into 1, which is count. So 8 into count. Now we'll do count plus plus. So count becomes 2, and counter is equal to counter plus 2. So counter becomes 5. Now, now the cells in this layer will be 5 plus 5 plus 5 minus 2 plus 5 minus 2, and this will be 16, and 16 into count. So now count is, this will be 8 into 1, 8 into 1, so this will be 8. So 16 into count. So count is now 2, so 16 into 2 is equal to 32. So total moves will be 32 plus 8, which will be 40. So as you can see in the test case, for 5 the answer is 40. Now suppose n was 7. So n was 7, 8 will be same, plus 32 will be same. So when counter becomes 7, the number of cells will be 7 in that layer. 7 plus 7 plus 7 minus 2 plus 7 minus 2, and each of these cells will take 3 times. So count is equal to 3. So it will be this into 3, and finally we'll add all of that to get our answer. Now how many times are we doing that? We're doing this n minus 2 times. So if n is equal to 5, we're doing this n minus 2 times, meaning 5 by 2 2 times. N is equal to 7, we're doing it 7 by 2 3 times. So this is what we're doing. So I'll show you guys my code. So this is my code. So if n is equal to 1, answer is 0, which is obvious. So now a is equal to n by 2. A is the number of times we'll be doing it. And initially I've made my answer as 8, and I'm starting the counter from 5 instead of 3. And count it is my variable count, and I'm starting that from 2. So while a greater than 0 and a minus minus, because I've already done with counter is equal to 3. So P is the total number of cells. So as I said, counter into 2, because counter plus counter minus 2 plus counter minus 2. So this will give me the number of cells, and count it will be the number of moves, and Q is equal to the number of moves into cells, the total number of moves. And that I keep on adding to my answer, and counter I keep on increasing by 2, because as you can see it keeps on increasing by 2. Counter is equal to 3, counter is equal to 5. Counter is basically the number of cells in the row of that layer. For example, this is the layer 1 to 8 cells, so the number of row is 3. This is the layer 1 to 16, so the number of row is 5. Counter is 5. So till that I keep on adding it, and the final answer will be in the variable answer. So the basic idea is we'll be moving layers of cell into the center position, and each of these layers will require count number of moves. So count is equal to 1, count is equal to 2, and so on. So that's it. Thank you.